Hello, and welcome to my first 40 videos that we're going to have. I don't know why I drew that arrow. I want to use the diagram. So, here's this problem for 1974. We have a pendulum. The length is L, and we have a mass M attached to the end. It starts at rest, but it's released from rest, and it starts swinging in circular motion. Then we have this really messed up P. At point P, the angle between the line's new position and its initial position, which we're going to refer to as the horizontal, is 30 degrees. So first we have to draw a force diagram at point P, which isn't that hard, because you're not going to need two components, you're just going to need two force acting at F and G, and in this kind of 30-degree angle, or actually it'd be 60 degrees, my bad, is FT. So now you're asking me something else. Now they're asking you, determine the speed. Well, I'll give you a hint. The best way to do this would be conservation of energy. And now you're going to ask, how do we get this? Well, remember that conservation of energy is KE plus PE plus, if you had any, which we don't, work on extra force equals KE plus the new potential energy. We don't have any friction or resistance, so we can safely ignore this term and just say K plus P equals K plus PE, or equals after. So, now we can figure out, first of all, we need to figure out what potential energy is. And this is the trickiest part, I think, of the problem. So let's take a corner plane here. And we have, say, this. Well, if our lines here, these are the same angles. This is 30, this is 30, this is 60, this is 60. From basic geometry. Now, sorry about that, I kicked my stand. I apologize. So, this is 30 degrees. And we need the height for potential energy. We have everything we need for kinetic energy. The problem is we don't have potential energy. So how do we do that? Well, we know the hypotenuse, and we know the angle, but we need to find this h. That's a right angle, and we can just use sine of 30 equals L over h. Therefore, h over L. So 1/2 L equals h. And that's all we're going to need now to plug into the formula. So, if it starts from rest, there's no kinetic energy to start. And we know at start, the height is the same because it's a circle. So the radius down here is going to be the same length. So I kind of drew right in the middle of my math there. So you know that is mgl equals 1/2 mv, what's it called? v squared plus 1/2 mgl. So first thing to do, we can cancel out all these m's. They're in every term, there you can cancel out. Now we subtract a GL, so we get 1/2 GL equals V squared, 1/2 V squared. So velocity simply equals the square root of GL. And that's a little crowded, I'll write this for you. People were giving me a chance. And there you go, you have velocity equals the square root of gravity, the gravitational constant, well not gravitational constant, gravitational acceleration near the surface of the Earth, times the length of the string. Gravitational constant would be big G, and that's a totally different concept we don't need to get into right now. Okay, that's velocity. I'm just going to keep that answer. Everything else is going to get erased for reasons that we're going to run out of space, and you really don't need to show your work again. Once you drive it once, you don't have to show it again. So, part 3 says, determine the tension of the string when the ball is at F. All you have to do is net force equals MA, and you're like, that's it? Yeah, that's it. Well, you know F of T minus, remember, we're at an angle. So mg is not simply mg. If you were down here or up here, it would be. But it's not here. It's an angle. It's on a horizontal or straight down, it's fine. But here you have a problem. Why you have a problem? Let me tell you. It's an angle. So there's components to the force of gravity itself. It's down here, but the motion's coming this way. So it's components. You have to use the vertical component, obviously. So Ft minus, sorry, I don't know why I ran out of breath there. Excuse me. So Ft minus mg sine of 30. However, mg sine of 30 is just mg over 2, as we discussed earlier, equals m. Now I'm going to skip a step and turn AC into, in terms of velocity and its length and mass. So Ft equals, I'm going to skip a step again, just plug directly in and simplify, equals mg over 2 plus mg. So f of t equals, sorry, you can't read that, too low. F of t equals 3 half mg. And I'm going to keep that, erase the rest of this. I made f equals ma a little too big there. And lastly, we want to determine the tangential acceleration. We have the centripetal acceleration now. So how do we find the, what should I call it, acceleration? Well, there's a couple ways you could do this. I think, personally, the easiest way would be to use our little angles here. So, we know F equals ma, right? That's one thing we have. So we know this. So this is the A we're looking for. Now we have to find a way to find force in the different term. So we know it's mg cosine of 30. Now, why is it cosine? Well, remember, centripetal is the y direction. So tangential must be the x direction. So you get F equals mg root 3 over 2. Simply simplify out. You can plug this now in for f equals ma. So mg root 3 over 2 equals a ma. Check this out. A equals 3 over 2g. You could use in terms of cosine. It's still correct. I just, because you can, converted that to a number. But you are free to leave in cosine if you want. And that concludes the first question in AP Physics C 1974. Hope you enjoyed the video, and soon question 2 will be up. Have a good day.